G'day guys, Mr. Bennett here. I just want to go through today an example of a transition matrix from a previous exam. This one's from the 2010 exam. So what it's looking at here is how movement of hire cars or vans happens. Alright, so we've got three towns here. We know half the vans will be hired out locally and half of them will be hired out for moves to town B from town A. From town B, 1/3 of the vans will be hired out locally, 1/3 are hired out for moves to town A, and 1/3 for moves to town C. And then from town C, half the vans will be hired out locally and half will be hired out for moves to town B. The company assumes that all the vans will be hired out each day and that all vans will be returned in time for the start of the next day. Right, so this is a scenario which you can imagine a rental car company would need to consider modelling this sort of mathematics. So for this one here, using the company's assumptions, write down the calculation to determine the number of vans that the company will have in town B at the start of the day, day one. Now here it tells you they start with 10 vans in town A, 30 vans in town B and 20 vans in town C. So obviously what we need to do there is we need to consider what's actually going on. Well, half the vans from town A will go to town B, so that's going to be 50% times by 10, which will give you 5. A third of the cars from town B will stay in town B, and half the cars from town C will go to town B. So that's going to be 5, 10 and 10, so that's going to give you 25 cars in town B. Right, so when we go to the next part, now the key thing about these questions, now with transition matrices, they can either be, as you would have done most of the ones in your textbook, they can go, so you have a row operation, or you can have column operation. So this one's saying this one is from day 1 to day 2. Okay, so it sort of moves the opposite way that you've probably been used to. So this is the starting point, this is what happens on day 2. Alright, so with this LX one, and that's a giveaway because that's a column matrix, the way they presented that. If this was a row matrix, it would be probably X times by L, and then that would mean day 1 to day 2. Alright, so you get the idea? So it's the same process, but just reversed in terms of the way that you read the operation. So we need to evaluate LX. Okay, so obviously if we do that, that will tell us the number of cars that are going to be in each place. Alright, so you just do that operation. You can do it in your calculator, and what that tells you is on day 1, alright, there will be 15 vans in town A, 25 in B, and 20 in town C. Alright, then the next part says find LX, L2X, okay, and you're going to get that answer over here. So that's obviously the number of vans in each town in day 2. So you obviously have to round that up. So 15.83 is going to become 16, 25.83 is going to be 26, and 18.33 we can assume is 18. Right. Now, if you go down to part C of this question, so they're very typical in the sort of things that they want you to do, and they want you to show that you understand what it actually means. So coming down to part C, describe what the company can expect to happen with the number of vans in the 3 towns over a long period. Well, that's talking about the steady state scenario. And we talked about that in class the other day, where we said anything with steady state you need to do something like L to the 100, and that will give you your answer. So in this particular case, what they're saying here is that's looking at as n goes to infinity, right? So if you do that calculation L to the 100 times by x, you'll get roughly 17, 26 and 17. Alright? Because it's a 3 by 3, we don't expect you to do the algebra. If it was a 2 by 2, then we might. Alright, so we'll go to the next part of the question. So very typical sort of things that you would be expected to do in a transition matrix question. Alright, then you go over here, we'll change the information. Then on day 0, we have 20 vans in town A, 20 vans in town B, 20 vans in town C. Write down this in the new matrix. Well, because we're putting that information about the cars, that has to go into a column matrix. So you'd be writing that information into that one there. So that's your answer there. And then ask you to go through and calculate what would you expect to see the number of cars going to be in each town in the long run. Because our original matrix, our L matrix hasn't changed, doesn't matter really how many cars you start with in any of the towns, ultimately you're going to end up with 17, 26, 17. That's what's going to happen, alright? Because the transition matrix will do that for that. You could start with all the cars in town C, and that's what will end up, in the long run, that's what you're going to get. Alright, coming back to this one over here. Alright, so part E, the company now, what they'll try and do is give you an extension part. So it's really just saying A, B and C are there. So explain why A plus B plus C must be equal to 1. Well, I mean, obviously, if we're looking at all the cars that exist in town B, that's got to add up to 100% of the cars that are in town B initially. Alright, remember we're going this way because it's this is from this town to the next town. So obviously all the cars that are in town A and B must add up to 100%, which is actually 1. Alright, so then we look at where they go. So you have to make a statement about that. So if x is equal to that, solve that for x. Now, obviously for this equation here, we've got 3 unknowns and we've got 3 equations. Now, this is a case where you can set this matrix up over here, right? So obviously you're timesing that out over there, you get your answer. You can solve that for A and B and C. Alright, so you're going to get 3 equations, 3 unknowns. You could also probably put that into your RRF and that would actually work out as well. So obviously a rearrangement of that will give you A is equal to that value. Now the only thing is, if I wanted you to do it exactly or do it algebraically, I'll probably say to you, find the exact answer. We'll show algebraically this is the answer there. Alright? So really what you're doing is you're doing the multiplication, and then what you're doing is you're equating. Alright, which is a useful skill that we continually do in maths. Alright, the last part of this question here says, how should the company interpret the values of A, B and C in part E2? Right, so then obviously out of your revision guide, which I'm showing you here, so in town B, 3/8 will be hired and moved to town A and C, right? 1/4 will be hired out locally, that's B, and then the remaining cars will be hired out and moved to town C. Alright, so if you wanted to, you could actually work out exactly the number of cars as well. So this is a very typical example of a transition question that you will get in an exam. There are a number of transition questions, and I'll just quickly show you from past exams. You can get a lot of these past exams online, and I can certainly give you a copy of them. So if we come down to this sort of question, generally nearing the end of the exam, I'll probably make a live me this time, won't be one in this exam, but typically there are. Okay, so here is an exam sort of question. So this is obviously question 17, doing row operations. Okay, so that's that sort of question, and then it leads into something like here where you've got an example with mining and looking at the mine construction. So they generally give you a way of getting into the question. Now another typical sort of question that you might get from here is, you know, the introduction of a species of animal or plant, and looking at that, how it's actually going over time. So you can transition that, or you might look at the population growth, looking at you know, like animals where they have young and old and that. So there are a range of examples for you to have a go at to do with transition matrices questions, and most of them are set up in the exam like a little bit different from the textbook. So just be aware of that and make sure you understand what's going on with those.